Good afternoon, everyone. Well, let's see. Let me switch over to my deck here. And while I do that, I've been told that I need to project my voice, so hopefully I won't come across as a shouty English person. But if I do, I'm in the right hotel because this place is owned by Gordon Ramsay, I'm told. So my name's David Syed. I'm a Principal Product Manager with Amazon Web Services. I joined about 2 years ago, actually, to focus on building a new media-related service. I spoke here at a similar event last year. At that time, we hadn't yet launched, so I couldn't tell anyone what it was. I now can, and I'm the product manager for the Amazon Elastic Transcoder service, which is a cloud-based transcoding service. Okay. Thank you. I think that's John's phone. Sorry, we're still not set up with a PowerPoint. Okay, while we're getting that fixed, I'll just go over the agenda briefly. So I'm going to talk about media workflows, where AWS fits into those media workflows. We'll talk a little bit about scalability as to why scalability is important, why you should care. And then we'll talk about some cloud media processing approaches. So try to show you how to put some of the theory into practice. Then I'll talk a little bit about Amazon Elastic Transcoder. And then we'll have a customer example from the visual effects industry. We were going to have Ryan from Atomic Fiction. Unfortunately, we had a snafu this morning with his flight out of Oakland. So we have Todd from Zinc. And Zinc do a fantastic technology to enable rendering of visual effects in the cloud. And then finally, we'll have another customer example, which is a broadcast example, broadcast playout to web publishing. So taking a feed from a playout system and creating VOD assets for web distribution. So I pause here. I'm just fighting with this machine. If I could perhaps get just a hand over here, please, to get my laptop screen synced up. So while we're doing that, I'm going to segue into talking about magic. Why am I talking about magic at this kind of event? Well, this very famous director said something which I think is really interesting, that magic and cinema have always been very closely related. The first cinematographers, the first directors were in fact magicians, and anyone who's seen the movie Hugo will perhaps understand that. One of the magician featured in Hugo was a key contributor to the cinematography industry. He created a number of special effects that we take for granted today, stop motion effects, trick effects, superimposition, all sorts of things that we take for granted in the industry today. And when we think about magic, you often think about the magic that's on the set. So here's a set. It's a beautifully lit set, I might add. You would never think so because I took the picture using my iPhone. But it was a beautifully lit set at the Mole Richardson stage down the road from a lighting workshop from a couple of years ago. There's this very lovely Arri Alexa camera that creates, rather like the F-65 that Ben was talking about earlier today, absolutely amazing images and massive images. I think the rate of creation of those images is something like 20 gigabytes for every minute that's actually shot. So fantastic. You've got all this wonderful data that's coming out that's capturing the magic on the set, and then you get to experience the magic in the actual Cineplex itself. This particular one is a very, very large screen indeed. It's a 4,000 square foot screen, and it's in Korea, and I'm told it's the largest in the world. To put that in context, that screen is the size of a basketball court. Must get one of those at home. But I would argue that the real magic, from a technical standpoint, takes place between the camera and getting the images onto the screen itself. It's the media workflow. That's the real magic. And we have a magic wand here. I was trying to get my daughter's magic wand, but she wouldn't part with it. So we have to make do with stock footage instead. And to do that, you have to, you have your workflows. You have at least one workflow. You probably have many more than one workflows. And that enables you to get from the on-set environment, the camera environment, to your finished production. But wait, there's more, because it's not just your finished production. You have all of these other things that you're trying to do with the content. Your archive, creating versions for networks, theatrical distribution, online, etc. And when you look at some of those, there's actually different versions. There's many different variations. You think of online, how many different versions might be created for the different devices that are out there. Think of how many different versions might be created for different networks or even theatrical releases in different countries. So you're going to probably insert a few more workflows there as well. And then there's this ever-increasing amount of content that's actually coming into the media processing chain, whether it's additional content for going onto the optical disc, whether it's interviews, the 2D version of the movie, the 3D version of the movie, the 4K version of the movie, the HDR version of the movie, and all the wonderful new technology trends that we are starting to see. And then, of course, you've got the archive materials and the stills and so on. So you have even more workflows to get from the left-hand side to the right-hand side, and that's really where the real magic happens. So where does Amazon Web Services fit into this media processing workflow? Well, as a number of folks have said earlier today, we really focus on the core services, the core infrastructure services. So we have compute and networking services. We have the storage and content delivery services. We've just heard from John about the storage services. You'll hear later on about the content delivery services, database services, deployment and management services, and application services, which is where the transcoder service fits. So that's great. You have all this underlying infrastructure and some managed services that you can actually use. On top of that, you might build the actual media processing elements, and this might look somewhat similar to what Ben showed earlier in terms of how the Sony C system is architected. So perhaps not these particular boxes are relevant to you, but some of them may certainly be, which could all get built on top of the underlying AWS services. Now, you might build some of these yourselves. You might already have a particular packaging system that you're using, or a content protection, or an authorization and authentication system that you're using, which you can then build on top of AWS. Alternatively, you might be using partners for some of these. John talked about some of the ingest partners available, for instance. The point is that all of these can sit on top of the AWS infrastructure. And then on top of that, you might have these higher level pieces of functionality, which again, you might either create yourselves, or you might go off and use a commercial or open source product and build that on top of AWS. So fundamentally, AWS fits into the media processing workflow by providing these various infrastructure level services and application services that you can then build on to create your own media workflows. So let's talk a bit about scalability. This is a chart that I'm told doesn't project very well, and I apologize for that. You'll see this chart on our website quite frequently, and it really is talking about why scalability is actually important. And is some of the concepts that Mark spoke about earlier in the day about the capital expenditure versus operational expenditure equation, and how you can trade capital expenditure for operational expenditure, because with the elasticity of cloud computing, you're not having to go off and pre-provision for specific workloads. Now, why do you care about that? Why is that important? Well, here's a few examples. One that I hear very frequently from online video services, for instance, and some distributors. The business has just signed a content licensing deal and now has this massive library of content that they want to get to their subscribers. They don't want to be held back by the media processing operations folks. They want to get that content in the hands of the subscribers immediately. So that processing all of that content will be a sudden spike that you would otherwise need to provision for if you're not able to do all of that elastically in the cloud. Another example might be a major event. It could be a sporting event. It could be some other kind of major event that's taking place and needs to be live streamed to a worldwide audience. Do you really want to keep building up that physical infrastructure and then tearing it down for every single event when you could do that in the cloud? Third example, talking about second screen type applications. You might have a second screen application on a tablet or a phone or some other device that ties in with some particular event that's taking place. It could be a prime time event. My wife is a big fan of The Voice. That is one of the few shows that she will watch live because she wants to talk about it to all her friends. So great, a second screen event. A second screen application might suddenly find that is generating a large amount of traffic as a result of that particular event that's taking place. And again, elasticity is the key to being successful there, rather than building out capacity that you need to provision for in advance. So fundamentally, the scalability is really giving you the ability to be agile. So in terms of approaches to media processing in the cloud, when I think about approaches, and this is really relevant whether it's media processing or any type of workload that's being moved to the cloud, there's essentially three phases. I teach a class at the University of Washington on cloud computing architecture, and it's one of the things that we talk about a great deal with the students who are coming from a variety of different IT backgrounds in terms of, from an architecture standpoint, how do you move either current workloads or create net new workloads in a cloud environment. So the three phases that we tend to talk about. Phase one is colloquially referred to as lift and shift. So you lift your on-site processing, whatever you're doing on-site, you package it up, you lift it, you deploy it in the cloud. And that's great. You've essentially moved it out of your data center and into our data centers. And so you have some advantages there. You have the paying for what you use. You're having a number of the advantages that Mark alluded to earlier in terms of not having to manage the capital expense. You've converted to operating expense. And you are also no longer having to manage that infrastructure yourself, that data center yourself. The second phase is to look at opportunities to either have some kind of hybrid model where you might have some on-premise processing and some cloud processing. We commonly see this with transcoding types of examples, and I'll talk about that in a couple of minutes' time. And then another approach is to look for opportunities to refactor and optimize the workflow that might be taking place. So as an example, let's say you have an application that you've built that relies on a database. Well, there's a couple of ways of doing that in the cloud. First way would be you just take your database that you're running on-prem and you move it into an EC2 instance, and you are now managing that database on the EC2 instance. It's entirely possible. Lots of people are doing that. It works very well. But another approach might be to look for managed database services. And we happen to have one called RDS, which enables you to run a managed MySQL, SQL Server, or Oracle database on AWS. And so one of the advantages there is that you are no longer having to manage the operational aspects of that database. You've given it to us to actually manage, but you're still able to use it like a regular database. Your normal SQL works. You're able to optimize your application to take advantage of that. And the scalability aspects of operating that database in the cloud are taken care of. Whereas if you were just running your straight database on an EC2 instance, those are some of the things that you would need to manage on your own. So that could be a simple example of how you could identify one area within an existing architecture, in this case a media processing architecture, and choose to optimize it. The third approach is to create a cloud-native architecture, which is really around creating a service-oriented architecture in the cloud, decoupling everything from everything else. And we'll talk about that in more detail in the broadcast example right at the end. But the idea there is to decompose your functional elements of the software into components which are designed to be resilient. So if something goes away, they are designed for failure. If something goes away, your system can pick off where it left off. So let's take a transcoding example. the lift and shift phase one approach would be to run your existing transcoding software on AWS. It's entirely possible. You could, for example, take your favorite transcoder that you're running on your Windows server, your Linux server, spin up the equivalent instance in AWS, fire it up, and have it run, and it would work just the way that you're used to having it work. The second approach, in particular what we see with transcoding, is the hybrid type of approach where you might run existing versions of the software, but you're actually running a cloud-optimized version of the software. So if you go into Amazon Marketplace, for instance, AWS Marketplace, where a large number of third parties make cloud-optimized versions of their applications available, you will find the likes of Harmonic, Digital Rapids, IntelliStream, and so on have cloud-optimized versions of their transcoders available. And that really enables you to have this hybrid approach where you might be using the same types of management tools, the same workflow that you use right now on premise, but when required, the transcoding software will burst into the cloud and use the cloud for excess capacity that's required. And so there are many advantages to doing that for you. It means you don't need to go off and buy additional hardware on-prem that you might need to use for that earlier example when a large volume of content shows up and needs to be transcoded immediately. And then the third cloud native version is to look at using a managed cloud transcoding service. Some examples there would be Amazon Elastic Transcoder, encoding.com, Zencoder. So these are all cloud-native transcoding services. And what that means is that there is no on-premise version. Your existing presets and so on will not transfer magically into these new versions. You will need to think about how you integrate and use the cloud-native transcoder into your workflows. And that may sound like a lot of negatives. Why would you want to do that? Well, a reason you might want to do that is because of the extreme low cost that these cloud-based transcoding, the cloud-native transcoding services offer, the extreme scalability that they offer as well. And we'll talk about that in a minute when I talk about Elastic Transcoder. So we built Elastic Transcoder in response to customer demand. Customers will regularly do this. They will come and say, you know, it would be great if you did function X. And as an example for transcoding, what happened was customers said, you know, we're storing media files with you in S3. We do transcoding on EC2. It would be really nice if you offered a transcoding service. And so we looked at the market and we thought, you know, there is an opportunity for, and Mark used this term earlier, the undifferentiated heavy lifting, to create a very commoditized transcoding service that is really targeted for creating transcoded assets for distribution type scenarios. So we designed the service for file-based, not live, file-based high volume transcoding. So the idea is that you can submit transcoding jobs to the service. You don't need to care about how it scales. The expectation is that it will just scale to handle the volume of jobs that you are sending it. We also adopted a very simple to understand and what we feel is a very low-cost pricing structure. This is my only pricing slide, I promise, which starts at $0.015 per minute of output. So we thought about how people think about video and media in particular. And there are many ways of thinking about how you might price something like this. But we settled on everyone knows how long, what the duration is of their content. So let's just charge that way. It makes sense to people. So we charge based on the number of minutes of output that you transcode. And we focused on what I'm calling OTT delivery formats. And I'm really talking about the web-friendly delivery formats that are out there. So if you're looking for something that does MPEG-2, cable labs type things, this is not the transcoder you're looking for. If you are interested in doing, for example, MP4, WebM, HLS file sets, this is absolutely a transcoder that you should consider doing. So we offer the fully managed cloud transcoding service. We're elastically scalable. So we take the scalability out of your hands. You just give us the transcoding jobs, and we will manage our transcoding fleet as we need to in order to scale appropriately. The outputs I already talked about. We're integrated across AWS services. So, for example, you think about AWS services, they tend to be very atomic, very granular in terms of how we've designed them. So when the service says it does transcoding, it does transcoding. It doesn't do ingest, because there are many good ways to do ingest in S3 over here. It doesn't do delivery because we have a perfectly good delivery service, CloudFront, today for doing delivery. So it does what it says on the tin, which is transcoding. We're available in multiple AWS regions. So you can look at our service detail page and see the regions that we're available in, and our intent is to go into other regions as and when we see customer demand. The other point is that we're API and SDK driven. So we do have a management console. It's a web page where you can go in and you can configure the service and you can create jobs, send jobs to the service. However, it's very much intended to be used for prototyping rather than you going off and submitting your 4,000 jobs through the management console, because that would get really, really tedious very quickly. So that's why we have an API. It's a JSON API. And we have a series of SDKs that are available for the popular programming languages that are out there on popular platforms. The way that AWS SDKs work is a little different to some other vendors. Our SDK, when you download, say, the PHP SDK as an example, it's an SDK that applies to all AWS services. So it will actually give you SDK calls for S3, for EC2, for Elastic Transcoder, et cetera, et cetera. And so there is no specific Elastic Transcoder SDK. It's all baked into the SDK that you download for the particular language or platform that you're using. We also recently introduced a command line interface for AWS services, which you can download. That also includes support for Elastic Transcoder. So how do you scale with Elastic Transcoder? So the first point to make is that what you really want to architect around the service itself. So think about sending us jobs as opposed to the way that you might be doing things on-prem today. You really want to think about sending us individual jobs and then configuring the transcoding service to handle those jobs in the way that you want it to be, in the way that you want them to be handled. You can use transcoding pipelines, and I'll give you a picture to explain that. So the way that we've set the service up is that when you create your AWS account, or you'll sign into your AWS account, and you go to the Elastic Transcoder console page, or you use the API, you can create one or more transcoding pipelines. You can think of these transcoding pipelines as queues, and you have more than one of them. So immediately you can see that you can actually transcode more than one thing at the same time. So that can be really interesting for certain applications. We don't tell you what you should do with these pipelines. We leave it up to you to use these pipelines in a way that makes sense for your particular workflows. Some examples. Some customers use a single transcoding pipeline for very short duration content, because guess what? That's going to transcode quicker than long-form content. And they might use another transcoding pipeline for that long-form content. Some other customers will use a queue management system and decide to keep one transcoding pipeline empty all the time, so that they are assured that if they get a high priority job that needs to be transcoded immediately, so-called live and late type content, it can be transcoded immediately because they have a free transcoding pipeline available. So there's many different ways to use transcoding pipelines. We're more than happy to give architectural guidance and insight into how you might want to use those. Inside the transcoding pipeline, that's where the transcoding jobs live. So the transcoding job contains a reference to the input S3 file, the output S3 file or object, as well as the transcoding preset that you want to apply to the transformation that you want to make. And these transcoding presets, if you've ever used a transcoder, our transcoding presets or profiles are very similar to others that you might have seen out there. As a managed service, we do not give you access to all sorts of fantastically detailed H.264 parameters, for example. If you want to adjust the windowing function that's used by the H.264 codec, this is not the transcoder you are looking for. If, however, you just want to pick a preset that is going to target an iPhone or an iPad or an Apple TV or a Kindle Fire, we have stock presets for that. If you want to create an HLS file set, we have stock presets for that. If you want to create your own stock presets, you can do that, and those are shared across your AWS account. So hopefully that's kind of a good level set for what Elastic Transcoder is and what it isn't. Another way to scale with Elastic Transcoder is we make extensive use of the Amazon notification service, AWS SNS, Simple Notification Service. And what this is, it's a publish-subscribe model that will basically let you know what is going on in your system. So if when a job is submitted, a notification can be issued. When a job has completed, a notification can be issued. If there's an error or a warning, a notification can be issued. And what this means is that you don't have to keep polling our API a million times a second to figure out what's going on. You just wait until you get notified. And that makes everything more efficient for every party that's involved. So in terms of the summary for the media processing part and transcoding in particular, 3 different ways: lift and shift, hybrid or refactor, cloud native, and really the right answer depends on your scenario. It depends on what you are trying to do. For some people, going cloud native is absolutely the right thing to do. For others, lift and shift is the right approach, and for others still, some kind of hybrid is the best approach. So we're now going to look at a visual effects example, and I'm going to start off with this fantastic quote about atomic fiction, and we'll see their demo reel in less than a minute. Atomic Fiction is a visual effects house. They worked on a number of movies that I'm sure you've seen, including Flight and the recent Star Trek movie. And they are extensively using Amazon Web Services, and they're using Amazon Web Services through a company called Zinc and the rendering technology that Zinc has created. So I'm now going to have Larry show the video reel, and then we'll have Todd come up from Zinc to talk about their technology. Thank you.
Cool. It's always great to see some of the work that some of our customers are doing, and every single shot you saw there was rendered on AWS in the cloud using Zinc. So my name is Todd Previs. I'm the CMO of Zinc, and I'm going to talk to you a little bit about our platform, how it runs on AWS, and some of the things we've learned by taking rendering, which is traditionally one of the most intensive parts of the visual effects and animation pipeline, and moving that entirely to the cloud. So some of the things that I'll share with you, you've probably heard from some of the other presenters. Some of them might be a little bit new, but I want to go ahead and really just discuss the origins of Zinc and how we've made rendering on the cloud available to users now. So Zinc itself is a cloud-based rendering and storage platform. So again, as I mentioned, if any of you have ever had to deal with rendering for visual effects or animation, you know it's a very tedious process. Using heavy compute cycles, as Ryan Tudhope from Atomic Fiction actually says, it's akin to watching paint dry. So it's not the most fun thing, but it's critical for providing great visual effects and great animation in our industry. So Zinc itself is a cloud-based rendering and storage platform, and we were actually written as a production tool, as most good visual effects production tools come out of from a post-production facility. So about 3 years ago, a couple of people started a company called Zero Visual Effects. They had worked at ILM, in Hydraulics, Asylum, so a lot of big visual effects shops. They started their own shop and really didn't have or didn't want to have to take out the capital that it will require to build out a huge render farm. I mean, this is a new company, but very capable of doing a lot of high-end work, much like Atomic Fiction. And that's where this idea was born. It was looking at Amazon, looking at alternatives for being able to use rendering as a utility or rendering on demand instead of having that massive overhead and those massive, the massive costs that go with it. So at its core, Zinc is designed just to look and feel like any local render farm. So to the artist, it's really seamless, but on the back end, it's running on AWS. As a commercial product now, we were in beta for about 2 years, working with Zero Visual Effects and Atomic Fiction, and working with several different software vendors to provide licensing. So you can see on the screen some of the applications we support right now. We support Maya, most of the popular renderers for Maya, as well as Nuke. So we've now rolled this into a complete pipeline package. It's been available commercially for about 5 months. And besides Atomic Fiction, we have customers now all over the world. We have customers in India, in Sydney, Australia. We have several customers in London. We have customers in New York, here in LA, up into the San Francisco Bay Area. So this is not just a tool or a solution that's for studios, but it really could be for individuals that maybe need extra horsepower for a job. So the results so far of what's been accomplished with Zinc, you can see over 7.5 million core render hours have been done on AWS. 15 feature films, we're adding to that every day. Hundreds of commercials and numerous broadcast spots. So you can see some of the feature films that were rendered on Zinc on the cloud. And a particular note, as David mentioned at the beginning of the quote that Bill Desowitz gave in regards to Atomic Fiction, all 400 visual effects shots on flight were done in the cloud using Zinc and AWS. And the power there is the scalability, which I want to talk about here in the next slide. I mean, this is the basic difference between your traditional render farm model or your traditional CapEx costs versus operational are pretty obvious, but these were the things that we really looked at when we developed Zinc and took a long, hard look at what makes sense for us. Do we want to build a farm? Do we want to take out a loan? Or do we want to do something that's unique and revolutionary and allows us to scale much beyond what you would typically have with a render farm? So all of the things that AWS provides with the cloud, and I'll talk about those in a little bit more detail in a later slide, really the things we looked at when we actually went ahead and created Zinc. So I want to talk some of the challenges we've faced in building a business in the cloud, and some of the things we've come across, as well as some of the things we've solved. So starting with the financial considerations, I mean, does it make sense for your facility to run on the cloud? And again, this has been addressed in other aspects of media production by some of the other speakers today. Maybe if you're a facility like an ILM or like a frame store, like a Double Negative, where you have shows booked for 18 months and you're going to have thousands of shots cranking on a farm 24/7, you want to keep those resources in-house. But the visual effects industry more and more is really becoming very nomadic. Jobs are moving between locations based on tax breaks. We're seeing that all the time now. We're seeing jobs moving out of LA to Canada, moving overseas. Shops grow, expand, and contract very quickly based on those jobs. And Ryan Tudhope from Atomic Fiction really likes to to talk about the ability at Atomic Fiction having an ILM-sized render farm 1 minute and an IMAX-sized render farm the next because of the scalability, but that also goes to the way that they treat their facility. So they did about 80 shots in Star Trek Into Darkness, and those shots match seamlessly with shots done by ILM, by Pixamundo, by these facilities with massive worldwide presences. But at the same time, Atomic Fiction is a much smaller shop, and they're really only scaling for these projects. So they might be several months between a job, and then they have to team up, bring in lots of people, and work on shots for 2 or 3 months. So it's that time in between, which we're seeing more and more of these peaks and valleys in the visual effects industry with the way the industry is going and with the way jobs are moving between facilities and between countries, really. So once sort of that has been established, taking the mindset of an all-you-can-eat to a pay-as-you-go model has also been somewhat of a challenge, moving from these capital costs to operational costs. Typically at a facility working with rendering, it's something you buy your render from up front and you run it into the ground. So now having to convince producers and show them that, look, you can actually budget this and you can charge this set amount of rendering to a job has been a challenge for us, but it's something that we've seen more and more people become favorable towards and start to use us much more because of that. So in choosing a cloud provider, when we actually wrote Zinc 3.5 years ago, there were many fewer cloud providers out there, but a lot of the things really stand true as to what AWS has offered us. And I want to go through some of these, starting really with the MPEA best practices audit that was done. This is a huge issue for anybody working in feature film, if you're doing television commercials, any sort of sensitive material, pre-release products, knowing that the data is safe, knowing that the data is secure, not just in an overall cloud environment, which all of these cloud providers have, and I'm not as familiar with the other standards, but really having the MPAA, the audit, having done the audit to meet or exceed the best practices of the MPAA is a huge selling point for us. We can tell our customers, I mean, your data is absolutely secure, you have nothing to worry about, and you should feel totally comfortable using Zinc. So that's I can't say how important that's been to us for moving forward with taking on more and more customers doing feature films and other high-profile work. Geographic coverage, really important. Having locations throughout the world is huge. As we design Zinc, and I'll show you in a slide later, it's meant to feel just like a local render farm. So an artist working in Maya can go ahead and kick off a render and say, look, I want to use 50 machines. I want to crank through the scene, and I want those frames, and I want them downloaded right back to my machine. I have a producer or director coming in an hour, and I need to have this done. So we're moving massive data sets and a lot of files with visual effect shots and with animation. So having low latency, being able to spin up a region in Amazon's location in Ireland for customers in London, and just minimizing that file I/O latency as much as possible is really important. That's one major benefit that we've seen in using Amazon. We have servers located both in the US and overseas, and like I said, we're serving customers in several different locations throughout the world. The infrastructure and development tools, John talked a little bit about Imaginatics. That's one of the companies that we're looking at to actually help expand our storage. We're using EBS now, but looking to improve that and to improve the speed. So again, just being able to have all these other companies that have written tools into AWS that allow us to basically expand and improve our own tools is really important to us. Cross-platform support, GPU availability, I put those in the same boat. As we look to support more and more host products, that maybe they're not all running on Linux, maybe some of them are running on Windows, maybe we're seeing more and more applications doing more GPU processing. So being able to have that flexibility and being able to work with all that is really important within the AWS infrastructure. And then I would say lastly, the last two, the adequate instance supply and proper machine types. Again, we're doing very specific, very heavy lifting that requires very beefy machines with a lot of memory, a lot of processing power. Being able to have those is critical. You couldn't do the job without it. And being able to call on literally thousands of 16-core instances for a project is important. Because as I keep saying, we have customers all over the world. So you get a time when you have 40 or 50 different customers hitting Zinc all at once, calling on all these machines. We need to be able to make sure we can scale and deliver these people's jobs to them as they need it. I was talking a little bit more about, a little bit before rather, about UI and integration, and where Amazon has been great in allowing us to provide these machines on the back end, giving people the feel of having a local farm. I'd say on the front end, the most important thing for us is making this a really seamless experience. So this is a shot here of Maya and the UI submission dialog within Zinc, but I think this probably goes to any sort of application that you're running on the cloud. You want users to feel as comfortable as they would if they're working in a completely local native environment. So anytime at all possible, we have plugins that we've written for both Maya and for Nuke. So users can go ahead, submit jobs to the cloud through Zinc. Zinc takes care of all the file management. Amazon does all the heavy lifting in terms of processing, and then we deliver those files right back to the user's local file store. So to them, it's really as if they do have an ILM-sized render farm in their back closet when they need it, and can turn that off when they don't. So making sure that people are really comfortable with the way new tool sets that are based in the cloud interact with their existing tool sets is a really important part of our workflow, we found. But back to the bandwidth and workflow issue, this has been repeated a few times already, and I have one slide at the end where I sort of theorize about this. But we are moving massive data sets, and being able to minimize that is really, really important for us. You're talking about gigs, if not terabytes of data going up and down from the cloud with all the live action plates you're sending up with Nuke and all the render frames that are coming back down at the end, both out of Maya and out of Nuke. So the way we try to mitigate this is to really look at the entire workflow and the entire pipeline and design a rendering solution not only for 3D but for 2D compositing. So if you look at the slide here, basically anything that gets rendered out of Maya or anything that's rendered on Zinc stays on Zinc. So the way our ideal workflow is, you render all your scenes in Maya on Zinc, they stay on Zinc, and then you bring those 3D scenes into Nuke, do your final compositing, and then when it comes time to render those, the Maya stuff is already on Zinc. It's already been kept up there as a copy, so there's no need to re-upload that inside of Nuke. You can simply hit render, minimize your upload times, and look at the final comp pretty quickly. So I see this more long-term, and I'll just show this in the last slide, of a really complete workflow where you have all the different steps from acquisition to final output or delivery working within a single cloud environment. Vendor licensing is something I want to touch on just very briefly at the end here. We've certainly found that different companies have very different attitudes towards cloud. If you're running your own software in the cloud, it's not a problem. If you're running, maybe you have a small facility, you're running your existing licenses in the cloud, that's one thing. But what happens if you're a facility that's got offices in New York, London, Sydney, and you have 10 licenses, but you really need to burst to 200 or 300? How do vendors work with you? So without naming names, I will definitely say there are certain vendors out there in the visual effects space that are much more open to the cloud and working with the cloud and have their strategy defined. And there are others out there who I think still need more time to figure out exactly what they want to do and how they want to work with you. So for anybody thinking of doing a cloud-based solution for visual effects, whether it be render licenses, interactive licenses, definitely needs to look at the way certain vendors treat the cloud and treat the licenses. Sort of lastly, I want to talk a little bit about the future and what I see eventually or ideally as a workflow. I mentioned before, the way it works now is people will render their 3D files on Zinc. They'll stay on Zinc, they'll composite those in Nuke, and then they'll get rendered out at the end. But ideally, what we'd like to see happen is something from the front end. Like, for example, I just picked Codex here. So seeing all of your files at acquisition upload to the cloud and really never having to touch a repeat or redundant upload. So by the time those live action plates are shot, maybe ColorFront or some other encoding system transcodes those to the files, to the EXR files you're working with in post-production. And then those files get delivered back to the client. So when the client has to upload those files to Zinc, you've already uploaded them. They're already on the cloud from the very point of inception, from the very point of acquisition. So then the renders are done, and then they're going to just go into another part of the pipeline for some sort of another encoding or distribution. And I also throw up Shotgun on there, as we've been working with them to do. They do asset management and project tracking, and they've done a really fantastic job of integrating into AWS as well. So we've managed the pipeline insofar as how we can go ahead and manage 3D and 2D in terms of the rendering situation. But when you really start to look at the overall production pipeline, where it goes is simply, I think, once those files are shot, they're up in the cloud, and there's never a need to upload those again. They just go from one step, one vendor software to the next step, allowing you to really minimize all the file I/O that still seems to be a bit of a bottleneck at times. So that's our take on the cloud. If you have any other questions, I'll be around the rest of the day. You can visit Zinc Render. So I'll turn it back to you, David. Thank you.
Well, I'm going to wrap up very quickly because it looks like we are running out of time. So if we can flip back to the PowerPoint, please. Well, I trust you enjoyed the stop motion effects in our video reel there. Intentional, I can assure you. So to finish up, I'm going to talk about a quick broadcaster example, play out to web publishing. So the objective, and I unfortunately can't name the broadcaster yet, but if you attend the Amazon reInvent conference in Las Vegas, they will actually be presenting. So it's an added incentive for you to go to Las Vegas. Their objective was to get broadcast content into their VOD player, and as soon as possible. So they have both live content as well as on-demand content. They also wanted to enable editorial clipping and review. And so what I mean by that is that you'll see in the architecture diagram, the block diagram, that they are actually acquiring live content directly from their playout system. And so it needs to get topped and tailed. I mean, there's stuff at the beginning, there's stuff at the end where the edits aren't seamless. They also need to create many different renditions for different output devices. And these are not just mobile devices, they're set-top boxes, broadcast-type devices as well. They also need to elastically scale for high-demand applications. Breaking news, sporting events would be two that immediately spring to mind. And they also wanted to have additional agility for different types of processing because all the time they have a requirement from the business to support new and additional devices. So super high-level workflow. There's essentially a parallel video SDI feed and a program data feed. So this would be the program information. The SDI feed is going into a broadcast encoder. That's actually sending 27 channels over RTP in chunks into Amazon S3. And the reason they do chunks is because it means that they can start to process things immediately rather than having to wait for an entire program to have completed transmission. They have live ingest logic that actually correlates the program data feed to the video content, creating metadata and so on. And then in S3, they'll reassemble the MES file based on those chunks. Then they have business rules that are running on EC2. And those business rules will do things like figure out what the right situation is, what the window is, and all of these different things that broadcasters need to worry about as to how long the content can be made available in the VOD system. They'll decide, depending on which outputs they require, whether to use Amazon Elastic Transcoder or whether to use the elemental transcoder. And there is a missing arrow there. The elemental transcoder does get a feed from somewhere. It's not just magic. My apologies. And what's interesting, though, is that, to Todd's point, the idea is to not move data around unnecessarily. So the transcoded asset is sitting there in S3, the version for distribution, for edit and clipping and so on. And so any of the other operations, DRM, quality control, editorial clipping, getting metadata into the media asset management system, as well as the distribution aspect that's not illustrated, is all keying off that same asset in S3. So the data doesn't have to move around. They're minimizing motion of the asset. Best practices that they found: componentize, decouple, and be stateless. Three main tenets of cloud architecture. Design for failure, another main tenet of cloud architecture. So if a particular resource goes away, it shouldn't mean that the entire system falls down. There should be a graceful way for it to recover. And the way to do that is through that componentization, decoupling, and statelessness. If data is in motion, use queues, and that's how you become stateless. So literally, when you actually see the real architecture diagram, at the beginning and end of each one of those arrows is a queue. Queues galore. Now, it so happened the guy who architected it did come from IBM, and he worked on MQ series, but that was the way that they chose to actually decouple the architecture. They also run at least 3 of everything for resiliency and redundancy. And that's another key point. Think of the cloud data center, the cloud infrastructure, as a set of fungible assets. It's a data center, but it's in software. You want another compute instance? Fire one up. You want another load balancer? Fire one up. You only pay for what you use. When you want it to go away, you can take it down. And then they log everything as well, so then they get a lot of insight into what's going on within the system. And then finally, they use frameworks where possible. So they're using a lot of open source frameworks and building on those because, why reinvent the wheel? And we have Netflix to thank for releasing a large number of open source frameworks, things like Chaos Monkey and so on, that will go out there and shoot instances to see whether indeed you've done a good job of componentizing and making things stateless. The results, quicker turnaround time, they only pay for what they use. They have an ability to support a larger number of target platforms because they can simply get more done within their system. It's extremely resilient, and they have a better control over their assets. So, parting thoughts, which you can read for yourselves. My parting thought to you, though, is there's a lot of us around today. We're around throughout the rest of the day and this evening. Do use us as a resource. We have a lot of experience collectively in building these sorts of solutions and helping customers to build these solutions, and use us as a resource to help you in terms of bouncing ideas off us. There's a number of solutions architects here, a number of product people here, a number of our customers and partners who are here who can give you some fantastic insights into what's working for them and what hasn't worked so well for them. So with that, thank you very, very much.